Hi, this is a video right here to help you learn how to balance some chemical equations. Alright, so this is balancing. Let me see, I need to get my little pins going here. So balancing chemical equations. Alright, now this is what I tell my students right here. I tell my kids that you find a problem, and when you find a problem you just keep working on it until you can fix it. Sometimes you have to double things too. So I've got phosphorus pentachloride plus water, and this is going to make hydrogen phosphate. I believe this is phosphoric acid actually, and hydrochloric acid, okay, which is HCl. All right, now let's use different numbers to be able to balance it. Okay, now if I look at this right here, I see we've got a problem because look, right here I've got 5 chlorines over here, but I've only got 1 chlorine over there. So we'll start right there and try and fix this problem. Okay, and it goes back and forth like a ping pong ball. That's what I usually tell my students. See, now I've given myself 5 chlorines, but look what I just did. I just gave myself 5 plus 3. I gave myself 8 hydrogens on this side. Okay, so what could I put right here to be able to balance this out? Okay, if I put a 4 right there, okay, now I've got 8 hydrogens on both sides. So I went first to this side, and then I went to the other side. Now I'm back and forth. Now, but this just gave me 4 oxygens. So let's check over here. I've also got 4 oxygens on that side, so that's good. Let's check our phosphorus. I've got 1 and 1. So evidently, this is right. Okay, and we'll just to make it right, we'll just highlight it. Okay, we'll just say we did a good job right there. Remember, Lavoisier says that there has to be the same amount of mass before a reaction as after reaction. This is why you have to have the same number of atoms before the reaction as after the reaction. Remember that these are called the reactants, and these are called the products. And since you can't create or destroy matter, you have to have the same mass before and afterwards. Okay, let's try another one here. Okay, let's do this one. C6H6O plus oxygen, because it's a Brinkelhoff, it's O2, and it's going to yield carbon monoxide and water. Hopefully I've written this down correctly. Okay, I just got some different reactions off of a website. Alright, so here we go. Let's use a different color again to be able to balance this. And remember, what we say is we're going to try to find out where there's a problem, and then we're going to address that, and then we'll just bounce back and forth like ping pong balls. First of all, see right here that I've got 6 carbons, so that means I've only got 1 there, so I'm going to put a 6 here. Okay, but now let's hold off on the oxygens for a little bit first. Okay, now let's also look right here. I've got 6 hydrogens. How could I make this 6? Well, if I put a 3 there, now I've got 6 on both sides. All right, now let's check our oxygens out. Now on this side over here, I've got 6 plus 3. I've got 9 oxygens on the right. On the left side, on the reactant side, right now I've got 3. Okay, but you know what? If I put a 4 here like this, that would be 8 plus 1. That would be 9. So this must be balanced now, because I have 6 carbons, 6 carbons, 6 hydrogens, 6 hydrogens, 9 oxygens, 9 oxygens. So let's just give ourselves a little reward, and we'll just say that that is all right. Okay? All right, so we're balancing it by bouncing just back and forth. Okay? All right, now here we go again. Now this one's going to be more difficult. Okay? All right, so this is C6H6S2. So C6H6S2. Okay? Plus oxygen. Okay? And it's going to make carbon dioxide and water and sulfur trioxide, SO3. Okay, I believe I've written it down right. Okay, now what we're going to have to do is we're going to have to just see if we can start solving these problems. Okay, now if I look at this, I've got 6 carbons on the left side, on the reactant side, so I'm going to start by putting a 6 there. Okay, now I've got 6 hydrogens. So over here I could put a 3 right there and take care of that, right? Okay, I've got 2 sulfurs. Over here I just have 1. I'm going to put a 2 there. So now everything is great. But now let's look at our oxygens, okay? Over here on the right side, on the product side, I've got 12 plus 3, that's 15, plus 6 right there, okay? So it's 12 plus 3 is 15 plus 6 is 21, okay? So it's 21. Is there anything that I could put in front of here to make this 21? All right? Not really, okay? If I put 10.5, that would work, but you can't have like half of an atom, okay? Can't do that. So this is what I always tell my students. Right here, if you would double everything, then it would work, right? Okay? So this is the time to go through here, and what we're going to do, I'll just use a different colored pen. We're going to go through and double everything. So this was a 1, so we're going to put a 2 here. This was 10.5, now that becomes 21. This was 6. Now this is going to become, instead of 6, this is going to become 12. This was 3, so this is going to become 6. That was 2, so this would become 4. And sure enough, that is the right answer. Okay? So let's just highlight this. We did a good job. There we go. And this is some explanation of how I teach my students to go through balancing equations. Just think about a ping pong ball bounces there, and then there, and then there, and then there, back and forth. And if you just keep chasing the problem through the equation, then logically you'll get to the point where the thing will balance. Okay? Sometimes you'll have to double everything to be able to make it work. Okay? But this is one way to balance the equations. Later you'll learn about redox reactions, and there's some different rules that you can use over there when you study more complex reactions. There is some different ways to balance them then that might be a little more easy for you. Thanks for watching.